Question 9, we have a curve for which the dy dx is given and it passes through the point 2 comma 3. We have to find the equation of the curve. To find the equation of the curve, we will integrate the derivative. So integrating dy dx, we get y is equals to, so we increase the power by 1, we get 5x minus 1 to the power 1 upon 2 plus 1 is 3 upon 2. We divide by the new power 3 upon 2 and multiplied by the derivative of the function. So the derivative of 5x minus 1 is 5 minus the derivative of 2 is 2x plus c. Now to find the value of c, we'll substitute the coordinates 2 comma 3. So substituting y equals to 3 and x equals to 2, we get minus 2 times 2 plus c. So 5 times 2 is 10, 10 minus 1 is 9. So 9 to the power 3 upon 2 will become 27, as the square root of 9 is 3 and 3 cube is 27 minus 4 plus c. So c is equals to 13 minus 54 over 5 plus 4. C is equals to 17 upon 5. So the equation of the curve would be y is equals to 2 upon 15 bracket 5x minus 1 to the power 3 upon 2 minus 2x plus 17 upon 5. Now in part 2, we have to find the double derivative. So dy dx is equals to 5x minus 1 to the power half minus 2. Differentiating this, we get half times 5x minus 1. We decrease the power by 1, so this will become minus half. And we multiply by the derivative of the function 5x minus 1, which is 5. The 2 will become a 0. So the final answer would be 5 upon 2. And we can bring this 5x minus 1 to the power minus 1 upon 2 in the denominator. So this will become square root of 5x minus 1. In part 3, we have to find the coordinates of the stationary point and we have to determine the nature of the stationary point. So for the stationary point, we know that the dy dx is equals to 0. So we'll put 5x minus 1 to the power 1 upon 2 minus 2 is equals to 0. We'll take the 2 on the other side. So this will become 5x to the power 1 upon 2 is equals to 2. Now to get rid of the power 1 upon 2, we whole square both the sides. So we get 5x minus 1 is equals to 4. 5x is equals to 5. So x equals to 1. Now substituting the value x equals to 1 into the equation to find the y coordinate, we get 2 upon 5 to the power 5x minus 1. So this will become 5 minus 1 to the power 3 upon 2 minus 2 plus 17 upon 5. Substituting this in the calculator, we get y is equals to 57 upon 15. Now to find the nature of the stationary point, we'll substitute this value of x equals to 1 into the double derivative that we found in the last part. So the value of the double derivative would be 5 over 2 square root of 5 minus 1. As this will give us a positive value and if the double derivative is greater than 0, we know that this is a minimum point.